These are notes on completing the square. In class, you've been exploring completing the square, and there are many, many different methods for completing the square. I'm going to show you three, and they kind of bleed into each other. You may find ones that you like more than another, so just be aware that there are many methods. You may have a method that I don't talk about that you like best, and that's fine also. So completing the square is the process that we use to transform quadratic equations from standard form to vertex form. By now you have found that graphing parabolas in standard form is really hard. You have to make a table, it's sort of a process of guess and check. So the easiest way to graph parabolas are when they're in vertex form. I can find the vertex, h comma k, and I have my a value, which allows me to figure out sort of how wide or narrow the parabola is and whether or not it's facing up or down. So the following task, we're going to talk about transforming these quadratic equations into vertex form. We're going to state the vertex, line of symmetry, and whether or not there's a max and min and what it is. The first method I'm going to use is algebra tiles. This may have been the method that you first started using in class as an exploration. Some of you may have moved past this method and no longer want to use it. Others of you may want to continue using this method, the entire way through the module. So we are given that f of x, we have an x squared, and we have 6 x tiles. So 1, 2, 3, 4, 5, and 6. And then we have minus 3 tiles. So I'm going to kind of put that over here, and I'm going to say that I have these, 3 unit tiles, but that actually I owe them. I owe them to the pile. So when I start making my square, I don't actually have these to put into my picture. So the first thing I want to do is I want to make a square. The x squared is already a square. And in order to make a square, I need to have the same width and the same length. So I'm going to take my x tiles and I'm going to split them in half. So I'm going to put 3 x's here and 3 x's here. So I now have used up all of these tiles that are on the left-hand side of this squiggly line. I've used the x squared tiles and I've used the 6x tiles. So now I need to fill in this remainder piece. And in this case, my remainder piece here, I don't have any little unit tiles to fill in. In fact, I have to borrow 9 tiles, and these were all borrowed in order to make my square. And then the dimensions of my square are going to be x plus 3 and x plus 3. And in order to get this borrowing business, I've already had to borrow 3 of them. That's what negative means, is I've borrowed 3 of them. So now I need to borrow another 9 of them. So I'm going to draw in another 9. I'm going to just kind of do this. Minus 9. And I need to borrow the 9 because what I've actually done essentially is I've added 9 here. That's what this is adding 9. And I want you to notice that I've done this in a different color because I want you to notice that by adding 9 here and subtracting 9, I haven't actually changed what I had because a positive 9 and a negative 9, they cancel. So now I can write my answer, f of x equals, I'm going to write my perfect square. That's x plus 3 quantity squared. But now I need to write my unit tiles in. So this side is this. I've now written exactly what I have on this side of my squiggly line. It's right there, x plus 3 quantity squared. But I still have the other side. I still have the minus 3 and the minus 9, which means I still have a minus 12. And I've now done the process of completing the square. So now I can say that my vertex is negative 3 comma negative 12. That my line of symmetry, and I use the shorthand L little o s, is x equals negative 3. I'm going to do a quick little drawing of my parabola, reminding myself because the a here is positive, my parabola faces up, which means I have a minimum of negative 12. Let's look at a second example. So our second example, we have f of x equals x squared minus 10x plus 30. So again, I'm going to start with my x squared. And I'm going to place these negative 10x's. Remember, I'm making a square, so I need to split them in half. So I have over here minus 5x's, and over here another minus 5x's, which means my dimensions are now x minus 5 and x minus 5. So my job now is to figure out what to do with this 30. So the 30, I can use the 30 tiles to fill in into this spot. When I do that, though, I am left with another 5 tiles. So I could almost rewrite this as f of x equals x squared minus 10x plus 25 plus 5. Remember, 25 plus 5, it is 30. So by just rewriting it, I've rewritten it, though, in a really special way because this is now represented right there, which means I can now rewrite the part that I've highlighted in that box as a perfect square binomial, x minus 5 squared. And then I still have this plus 5. So my vertex is 5 comma 5. My line of symmetry is x equals 5. And again, I'm going to draw just a quick sketch of this. My a is positive, so my parabola goes up, which means I have a minimum of 5. My third example using the algebra tiles is f of x equals 2x squared plus 16x plus 13. There are many ways to do this problem using algebra tiles. What I am going to do here is I am going to sort of ignore my 13 for now. So I'm going to kind of put a box around it and I'm going to ignore it for a few minutes. And instead I'm going to focus on my 2x squareds plus 16x. And the reason I'm going to focus on that is because 2x squared means I have an x squared and an x squared. So I have 2 of them, but I need both of them to be the same squares. So I need to take the 16 and I have 2 of them, which means that I have 8 to put with this x squared tile and 8 to put with that x squared tile. And in order to get my dimensions of length and width to be the same so it is a square, I split my 8x tiles in half, put them on each side. Same thing here. Which means I now know my dimensions are an x plus 4 and an x plus 4 and an x plus 4 and an x plus 4. And now I have to fill in the missing piece. So filling in the missing piece, I'm going to have plus 16 and plus 16. So now I kind of need to figure out this 13 business. So I have 13 tiles to place in these green spots, in my plus 16 spots. So what that ends up meaning is that I place my 13 and I'm left with 3 empty. So need 3. And then I need all 16 here. So remember in that first example when we needed tiles, we ended up having to sort of borrow them from an extra pile. So what ends up happening is that I need to borrow 19 tiles. So I'm now going to write this, that's x plus 4 quantity squared, but I have 2 of them. And I used my 13 tiles up in this box, but I needed an additional 19, so I borrowed 19. Okay, we're now going to look at 2 other methods, but kind of at the same time. So, one way of completing the square using algebra looks like this. So I have f of x equals x squared plus 6x. And then I'm going to add something and subtract something, and then I have my minus 3. Now, in math, I can add something to both sides of the equation, keeps it the same. I can also add 0 to any number, and it keeps it the same. So what I end up wanting to have is I want to have this equal 0. So I could add 9 and subtract 9. I could add 12 and subtract 12. I could add 50 and subtract 50. I could add anything and subtract anything in those spots in order to make it be 0. The catch is I want something really special because I want this portion to be a perfect square. And you'll remember from earlier in the module that in order to complete the square using algebra, I take my b value, divide it by 2, and square. And in this case, my b is 6. So divide 6 by 2 and square, which is going to equal 9. So I'm going to add 9. That allows me to write the part that's in the purple box as x plus 3 quantity squared, which is what I want. However, I need what's highlighted in yellow here to be 0 so that I don't change the equation. I don't want my equation to have a different value. I simply want it to be dressed up in different clothing. So what plus 9 makes 0? Well, minus 9. And so now what I have taken care of here, what's in the purple box, so I now need to take care of what's left in the equation, which is minus 12. And our vertex here is negative 3 comma negative 12. Our line of symmetry is x equals negative 3. And we have a minimum of negative 12. Now, there's a second algebraic way of doing this problem. So I'm going to just draw a line here to indicate that I'm using a second method, so or the third method. So this is the second method, and this is our third method. Completing the square using algebra tiles was our first. So in this method, I am going to move my negative 3 to the other side. I'm then going to complete the square here, which means I'm going to be adding 9 here. But remember, if I add 9 to one side of the equation, I also have to add it to the other side, which means I have the equation f of x plus 12 equals x plus 3 quantity squared. And the last thing I need to do to make it look like vertex form is to simply move my 12 over. So f of x equals x plus 3 squared minus 12. And obviously my vertex, line of symmetry, and minimum are going to be the same. My second example, Again, there are several ways to do my second example. In fact, I may actually do this in 3 different ways. We'll kind of see how it works out. So the first way is that I am going to say f of x equals, and I am going to factor out a 2 here. So that I have 2x squared plus 8x, excuse me, and then I have a plus my completing the square portion, which means I also need to have a, oops, which also means I need to have a minus my completing the square portion, and then I still have my plus 13 over here. So I'm going to complete the square in here. I'm going to ignore the 2, I'm going to ignore the 13, and so I take my 8, divide it by 2, and square it, which gets me 4 squared, which is 16. So I'm adding 16, but I'm also subtracting 16. Remember that I don't want to change the value of my equation. I simply want to change the dressing of my equation. And so if I'm going to add something on one side, I also need to subtract that same thing so that I'm really only adding 0. I now am going to have to kind of do 2 steps at once here. So I actually want, you'll remember from above, I actually only want this portion when I'm completing my square. So really I want just the x plus 4 squared. So I need to figure out what to do with this minus 16. I still have it in the parentheses, but I don't want it in the parentheses. I actually want it outside of the parentheses. So I am going to leave my 2, and I'm going to use a big bracket here, and I still have my minus 16. But I need to somehow combine this number with the 13. So what I end up doing is I end up distributing the 2 to both pieces here. So 2 times x plus 4 quantity squared minus 32 plus 13. Remember, we're treating this x plus 4 quantity squared as just one number. So I am just simply multiplying this number by 2. And so I don't actually do anything with putting the 2 inside the parentheses. I can't do that in terms of order of operations. I'd have to do exponents before I can do multiplication. But it might be easier just to think about this as one whole unit. You could think about this as just being the letter A, and so I have 2A. And then I simplified this side. So 2x plus 4 squared, and that would be minus 19. So my vertex is negative 4, negative 19. Let me double check that. It may not be negative 19. I feel like I'm doing my math a little too quickly in my head. And it actually should be, yes, it is negative 19. Okay, double check that, so I'm good. So I have my line of symmetry is x equals negative 4. My parabola faces upward, so I have a minimum of negative 19. So now let's look at another method for completing the square here. Pretty similar to the second method I used above in the first example in this section. So I'm going to move the 13 over. So f of x minus 13 equals 2x squared plus 16x. And then, similar to what I did above, but it's a little more complicated because I have this 2 in front of the x squared, is I'm going to get rid of that 2, which means I'm going to divide everything on both sides of the equation by 2. So I'm going to have my f of x minus 13 divided by 2 equals x squared plus 8x. So now I'm going to complete the square. So I'm going to add 16, but that means I also need to add 16 to this side of the equation. Now I have f of x minus 13 all divided by 2 plus 16 equals x plus 4 squared. And now I need to move everything that's next to the f of x over to the other side. So the first thing I'm going to move is my 16. So f of x minus 13 over 2 equals x plus 4 squared minus 16. Multiply everything by 2. So f of x minus 13 equals 2, x plus 4 squared minus 32. And then add 13 on both sides. So f of x equals 2, x plus 4 squared minus 19. So the same exact answer. Again, there are many other ways to sort of work this problem. And you may have seen a method used in class by one of your classmates that you like better than this. So, play around with what method is most comfortable for you. We're going to do 2 more examples because this is definitely, the problems do get harder. And the reason the problems can get harder is because we start introducing fractions, which tends to make many people a little nervous. But if you just remember that you're doing the same things each time, it's just that your numbers are going to look a little different. So the first way I'm going to do this problem is saying that I have x squared minus 9x plus something minus that same something plus 30. And this is where the numbers might scare you off a little bit, but I want you to watch what I'm going to do very carefully because it actually is easier than you think. Now remember, in all my other problems, I took my b value and divided it by 2. I'm going to do that exact same thing here. And then I'm going to square it. Now, at this point, many of you are going to say, but negative 9 divided by 2, it isn't a thing. It's a fraction still. It's like negative 4.5. And I'm going to say, yes, indeed, that is entirely true. But I'm going to argue that at this point, especially if your teacher is not having you use a calculator, which I would not be having you do necessarily, you're going to want to leave it as a fraction because you know what negative 9 squared is. And you know what 2 squared is. You don't need a calculator to do that calculation. You already know that, which means I can now say I am adding 81 over 4 and subtracting 81 over 4. I can now write, so remember, there's my 0. Here's my perfect square trinomial. That's going to give me x minus 9 over 2 quantity squared. If you haven't already noticed this pattern, in order to factor the perfect square trinomial, this number right here is always going to be your b divided by 2. And it actually works out that it's also exactly your square root of your c term. Okay? And now I still have minus 81 over 4 plus 30. Now, again, this is a situation where you may start to get a little nervous about what it is that you're supposed to do because you're looking at this and you're saying, but there are fractions here and I don't know how to work with fractions. So a reminder here, I can rewrite any number in a multitude of ways. I could say that 30 is the same as 30 over 1, is the same as 60 over 2, is the same as, etc. I want the same as where the 4 is, where the 30 is written so that it has a denominator of 4. So still have my minus 81 over 4, but I want to rewrite my 30 so that it's some number over 4. So I'm going to need to ask myself, what number divided by 4 equals 30? Well, it's 120. So I now can simplify negative 81 over 4 plus 120 over 4 is going to be a positive 39 over 4. And I have completed the square. So my vertex is 9 over 2, comma 39 over 4. My line of symmetry is x equals 9 over 2. And because my parabola is facing up, has an a of 1, I have a minimum of 39 over 4. Now, I could do this problem again by moving the 30 over to the other side. It looks the same, but let's look at that work so that we can be sure that if you like this third method better, you can see it. So the first thing I'm going to do is move my 30 over. So f of x minus 30 equals x squared minus 9x. Again, I've already done the completing the square part, so I'm going to add 81 over 4 over here, and I'm going to add 81 over 4 over here. On my right-hand side, I have f of x, sorry, my left-hand side, excuse me, I have f of x minus, I'm going to rewrite 30 so that it's some number over 4, plus 81 over 4. In order to have this some number over 4 be 30, it has to be 120 over 4. On my right-hand side, I can now write that as completed as a perfect square binomial. And then I can simplify this as negative 39 over 4, which means when I move it to the right-hand side, I get the exact same answer as I got in the first method. Okay, the last example is when my a is no longer 1. All of the problems we've done so far in this third method, my a has been 1. So now I'm going to look at a problem where the a is not 1. I'm going to do this problem only once this time because it's going to be a fairly larger problem, and it means it's going to take up more space than we've seen with the others. For this one, the method I'm going to use is similar to the second method I used in the second example in the method 2 way. So the first thing I'm going to do is I'm going to move my 39 over. So I have f of x minus 39 equals negative 3x squared minus 5x. I then want my coefficient in front of my x squared to be 1, so I'm going to divide everything by negative 3. So I have f of x minus 39 divided by negative 3 equals x squared minus 5x over negative 3. I can simplify this slightly, so I'm going to have x squared plus 5 over 3x. And on the left-hand side, I still have my f of x minus 39 over negative 3. So I now need to complete the square. And when I complete the square, I still am taking my b value, so 5 over 3 divided by 2 squared. But you'll remember that dividing by 3 is the same as multiplying by 1/2. So I end up with 5 over 6 squared, which is 25 over 36. I'm going to add 25 over 36 on the right-hand side, and on the left-hand side. My right-hand side, I'm now ready to write it as a perfect square binomial. So x plus 5 over 6 squared. And the nice thing about showing your work for taking your b and dividing it by 2 and squaring it is that you'll always end up with the part of your perfect square binomial at this step where you have your b over 2 simplified. So now I need to deal with my left-hand side. There are many ways to deal with this. I think that the method that I'm going to use here is that I am going to start, I'm just going to rewrite this, by moving my 25 over 36 to my right-hand side. So I have x plus 5 over 6 squared minus 25 over 36. Still have f of x minus 39 over negative 3. I'm then going to multiply everything by negative 3. So I have f of x minus 39 equals negative 3 times x plus 5 over 6 squared. And when I multiply negative 3 by 25 over 6, we'll show that work over here. So negative 3 times negative 25 over 36. My 3 can go into itself once, 3 can go into 36 12 times, so I end up with positive 25 over 12. And so my last step is going to move my 39 over. Now, when I move my 39 over, remember, I'm going to want I'm adding 39. I'm going to want my 39, I seem to write 39 correctly. I'm going to want my 39 to equal some number over 12. Well, in order to get 39 to be some number over 12, I have to multiply 39 by 12. When I multiply 39 by 12, I end up with 468. So I'm really adding 468 divided by 12. So 468 divided by 12 plus 25 divided by 12. So now I have f of x equals negative 3 times the quantity x plus 5 over 6 squared plus 493 over 12. And I run out of space here, so we'll take another page and sort of move this up a little bit and finish writing the last part of this, which is my vertex and line of symmetry. So let's see, my vertex is negative 5 over 6, comma 493 over 12. My line of symmetry is x equals negative 5 over 6. And in this case, I have an a that's negative, which means for the first time out of all these problems, I finally have a parabola that's facing upside down, which means I don't have a minimum, I have a maximum of 493 over 12.